Dimitri Desmidt from A10 Networks. So a few challenges here for me. First, I'm the one after the break. So now you're full and ready for a nap. So I'll do my best to keep you awake. My second challenge is I'm a vendor, and my title has marketing in it. So usually people don't really believe me. But OK, I'll try, at least for today, to not talk about A10 network specific, but more load balancers, what they can do for you, and network devices, what they can do for you, without mentioning A10 networks too much. And what else did I want to say? And yeah, my third challenge is I'm on a topic that is roughly the same as the two topics before. So I agree with them. The best way to learn something is to play with it. How do you learn how to drive a car? It's not reading a book. I mean, you can read books. There are great books, for sure. But how do you learn how to drive a car? You drive a car. So how do you learn how to move to V6? You have to go there. So there are different solutions, different techniques, different things to do, different challenges. Those have been, or many have been talked about before. Let's talk about now what load balancers can do for the enterprise and network gears can do for the service providers. And that's what I will talk about in my 30 minutes. So now I'm talking about the enterprise and focusing about the enterprise. So what can load balancers do? So what do you have today? I won't talk about how to deliver IPv6 up to your employees in their cube, in their offices. I'm focusing about how to provide IPv6 services to your end customers or to the world. So you have today what? Most likely you have an ISP or maybe two ISPs for high availability and an IPv4 connection to internet. And you have services, web, mail, I don't know, maybe some file transfer stuff. OK, so different services available today to your IPv4 customers. Great. And I'm missing here maybe some stuff you do have, or most likely you do have, firewalls and things like that. OK. You may have this as well. Actually, most enterprises have load balancers already. So what does those guys do is, of course, split the load among servers to give you more scalability and high availability. If one server crash or one application on the server crash, the load balancer will detect that and split the load from your different users among the different available servers and applications running on them. So you have most likely this, or maybe only this. Fine. How do you jump to a service IPv6 easily for your IPv6 customers? Or to show for competitive advantage you're there, or for various reasons that has been talked about, you want to deliver IPv6 services to the world. So an easy way to do that is you use your existing load balancer if you have one, or you buy one and you have a variety of load balancers from very expensive to very affordable. So depending on the traffic you have, the load you have, that can be very, very cheap or expensive. But most likely enterprise, you're not like Google, Yahoo with gigs and gigs of traffic, so that can be very affordable. Or free, if you already have a load balancer supporting that. Most of them do, not all of them. We had Luc, but he's from Canada, so I can say the French with a French accent. So we had Luc with one vendor not supporting it. Of course, we do, but many other vendors do support IPv6 and can help you there. So if you have a load balancer, that can be actually free to provide IPv6 services. Using what? Using your existing v4 servers with the applications running on your v4 servers. So you don't have to buy new servers. You don't have to test or use dual stack on your existing servers to test your application will work or not work with IPv6. Actually, some application vendors don't support IPv6 yet. That's in their roadmap. That has been in their roadmap for a long time and is still there. Some already do, but many don't. So how do you provide v6 services for applications not running on v6? That's an easy way. OK, so how does that work? v4 clients talk to their load balancers as of today, and are load balanced to your servers. Great. v6 clients, they talk to a virtual IP on your same load balancer, and this guy will translate the v6 clients to the v4 servers. So your servers are the same as today, and they talk to v4 clients, or actually they talk to the load balancer on v4, and this guy does the translation in and out. So you don't need to change anything. If you don't have a load balancer today, or if you do have a load balancer today not supporting that technology, which is called SLB-PT, Server Load Balancing Protocol Translation, or some vendors call that SLB 624. If you don't have one, or if it doesn't support it, you add that one on the side. v4, no impact, not touching the new load balancer, still go to your server. v6 clients, they go to, oops, how did I do that? Ooh. v6 client go to the load balancer, does the translation, and that's simple. OK, so what are the prerequisites? First, what are not the prerequisites? You don't need to buy servers. You don't need to turn on dual stack on your existing servers. You don't need to validate your applications run on your new servers or on those old servers with dual stack, because those servers are the same, running v4 with the applications running on v4. No change on them. You don't touch them. What are the real prerequisites? OK, so first, you need v6 access. If you don't have v6 access, then customers cannot talk to you on v6. That's pretty simple to understand. It does take some time, not much, to do it. Actually, as Luke mentioned in his experience, as soon as you pay them, usually they are pretty fast to deliver it. It took them just one day. Once they paid, it took them, it's a university, 2 months to pay. But when they paid, they had the IP addresses just behind. So you have your IPv6 block, IP addresses block. You update your DNS. If you're an enterprise and you don't own your DNS, you ask your DNS service provider to update the entry for your www, for instance, and maybe your mail. So www.mycompany.com has an IP address v4 a record, which is 50.50.50.50. That's what you have today. You just call them, or if you own your own DNS, update your DNS server and say www is also an IPv6 address, quad A, with, I don't know, 3000 colon blah, 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 blah. You know how easy to remember they are, those addresses. So you update that. That's what we've done actually for A10 networks. You can use the same name. You can use different names. As a vendor, I don't mind. Now we're talking about tests in this scenario. So for test, what you could do easily is another name. So you have your www with a v4 address, IPv6, or test, or whatever, with your www with your IPv4, IPv6 with your IPv6. Now, I do recommend, at the end, when you're in production, to use the same name, because people and all the links, all the different other websites pointing to you will use definitely www. Then you need to use your existing load balancer device, or if you don't have one, or it does not support SLB-PT, buy one. Again, they can be very affordable. It goes from a few $1,000s to, OK, crazy expensive if you have hundreds of gigs of traffic, but in the enterprise, I doubt it. And then you validate it's working. That said, it should really work. there is no reason for not working, because what? Your servers are still the same v4 servers with your applications running v4 that were working for years, and they are still working v4 and so on and so forth. So that should definitely work. So what are the gotchas? What you have to keep in mind? There is one flaw in this integration. What is it? So clients talk to your load balancer on v4 and to the servers. Great. The servers keep the visibility of the v4 client IP address. It's all good. Marketing people are great because they can track users. Security people love that because they can track users and do what they want to do. Now, if we look at the left, on the left, v4 clients talk to your load balancer on v6, to the IP address v6 for www, which is hosted on the load balancer. And then the load balancer will talk to the servers on v4. So, of course, it will change the destination IP address to the server IP address. OK, fine. But it will change the source IP address client v6 to its IP address v4. So now, what is the source IP address seen by the server? No more the real client IP address, but the load balancer. So if you care about the IP address of the client, for security reasons, for marketing, for tracking, for whatever, you're out of luck. Now, web applications, they can use cookies, they can use different things, so most likely you don't care. But if you do, you're out of luck. That said, some load balancers, and definitely mine, they have a trick for that, a workaround. This workaround works only for web, HTTP, HTTPS. So if you need that for mail or different other applications than web, HTTP, HTTPS, there is no trick. Okay? What is the trick, briefly? The trick is with the load balancer, not we. Okay, it's vendor independent. The load balancer sees the real client IP address. So the load balancer will inject the real client IP address in an HTTP header. I don't know if you know HTTP very well, but you have headers. So it will inject the real client IP seen in a header. And on your servers, you have to configure your servers to know that the client IP address is not at the layer 3 on the source IP, but in the HTTP header. If you don't know how to do that because you're more networking guys than application guys, most vendors, and actually I did for my company, a deployment guide, a tech note, I think it's called, a tech note explaining you how on Apache, IS6, IS7, how to do that. It's crazy simple. Click, click, click. An Apache, OK, it's not click, click. It's an httpd.conf file to edit, but it's one line to change. So nothing very hard to do. But keep this in mind. OK, now another thing to keep in mind. This technology, this solution works great for most of the applications. Web, mail, LDAP. I don't know why you will have LDAP on the internet, but anyway, works great. Does not work great for all applications. Some applications, like FTP, like streaming, like SIP, I think I mentioned all of them, they don't work on one unique UDP or TCP port. They have multiple ports and quite dynamic. Like FTP, you start on one port for the control and another session for the data transfer. So firewalls, let's talk about v4 only. Firewalls, load balancers, they need to understand the protocol to be able to do their job because there are multiple ports to follow. So that's called ALG. I even forgot what it stands for, but whatever. So for v6, that's the same because we do the translation between v6 on the client side and v4 on the server side. So you need a load balancer with an ALG to be able to do all the flows the way it should do. Okay? So keep this in mind when you select your load balancer. Okay, I did a workshop where actually people did the configuration, of course, now on my product. to provide a service that is existing on v4 and do it on v6. So I can show it to you how easy it is. That's pretty simple. And I will finish there, almost there for the enterprise, and then we'll talk about the service providers. So I go on my AX management. I go on my AX. I'm using name because IPv6 addresses are much more complex to remember. And yeah, I'm a marketing guy, so of course I cannot remember a lot of things. Okay, so that's my IPv6 of AX, which is actually just there. Of course, we do support management on v4, but since we are talking about v6 here, I do the management on v6. So how do I do the trick? I have my server on v4 only, running an application, which is running on v4 only. So I define that in my load balancer, and I create a VIP. VIP stands for virtual IP address. So it's not the physical IP address of my server. It's a virtual IP address hosted on my load balancer, which is FD's whatever. I created a DNS name for that, 10networks.com. Okay, that's the same IP address, v6. So this DNS name has name has a v6 address, which is my v6. And if you look at under monitor, this v6 address for TCP port 80, so for web, goes to that server. Okay, that's this simple. I define my server, my real server v4. I define my VIP, v6. And when traffic comes to my VIP, I go to that server. So if we look at my v4 server, I created a name for that, S1 v4. So you see that's an IPv4 address. If I go on this IP address, S1, oops, my PC wants to wake up, v4 at10 networks.com. I go to my website. Okay, great. If I go, let's close that. If I go to dub1, let me change that. Dub1. What is my application? What is my web server? Or my web application? The same thing. I have exactly the same content, and of course I talk to the same server. Okay? So it's very easy for people to provide IPv6 services using their existing IPv4 servers and applications. Okay? So really, that's, by the way, this technique has been used a lot during the World IPv6 Day, of course with our customers, but I'm sure with some other competitors' customers that have similar techniques. Very powerful, very easy, very affordable, can be free if you have a load balancer supporting it. Can be, okay, not free if you don't have a load balancer supporting it, but they are very affordable. Okay, and with this load balancer, what can you do on the top of this? For the same amount of money, you have this load balancer giving you IPv6 services, but that load balancer can give you more benefits than that. Can give you load balancing, so if one server can do that, now you have two servers, so you can sustain this much load. And if your service is very popular, just buy another server from HP or Dell, a community server, and now you can do that much, and so on and so forth. High availability, if this server dies, you have now multiple servers hosting this application. So your server or the application running on that server dies. The load balancer will detect that and remove that server from the load balancing. So for the end users, that's completely transparent. Your service is still there. Many more benefits than that. High visibility. You can track how much traffic you have, how much not only bandwidth, request, type of request. So plenty of visibility on your applications. You can offload your servers. If you provide a service which is HTTPS, SSL use a lot of CPU on your servers. What you can do is you talk SSL up to the load balancer and HTTP up to the server. So now your server on HTTPS can do that. On HTTP, it can do that. Your server is doing HTTP, so it can deliver this amount of traffic. But the service is still HTTPS because SSL is terminated on this powerful box, able to do lots of SSL stuff. Many other benefits. Protection, we can talk about that, but that's not the goal of that topic to talk about load balancers. So I'll skip security and flexibility that can be provided by load balancers. So really easy for you to go, few clicks. People did it in a lab yesterday in few clicks, and gives you lots of other benefits. You should definitely look at that. Now for service providers, I close the door with the enterprise, how to provide IPv6 services for your end customers. I opened, and I say that's very easy, and it's true. Now I open the door for the service providers. That's not that easy for them. Actually, you've seen AT&T talking. They selected a solution, 6RD. You've seen Telecom Italia. I forgot where she is. She selected something else, DS Lite. Why that? There are many solutions for the service providers. They have the same challenges, which are, hey, I'm running out of IPv4, and if I call Erin, or in Europe, that's someone else, but if I call somebody to get more IP addresses, they are running out, or they ran out. In APAC already, in Europe soon. So I cannot get IPv4 addresses to provide services to new customers. I'm a service provider. So that's their first challenge. And the second challenge is they have customers, okay, mainly today geeks, okay, but not only today actually, that want access to IPv6, and they want to have more of those customers. And if they don't provide this service, those customers will go from Telecom Italia to their competitor. So they really have two challenges. They cannot accept much more customers because they're running out of v4, and they want to give IPv6 services. So why there are many solutions? I'll skip that because I will run out of time. There are solutions for both challenges. One around NAT for the IPv4 starvation. Of course, NAT has challenges. It's not perfect. For the IPv6 access, they are dual stack, encapsulation. Not a lot of service providers look at dual stack. Why? Doesn't solve the first issue. If I give to my home users dual stack, a v4 and a v6, I still have to give a public v4, so it doesn't help me on one of the two challenges. And now I gave v4 and v6. So what about troubleshooting? If a customer contacts me and complain, is it because IPv4 is broken? Is it because IPv6 is broken? The billing system, what do I use? So it's complex. Lots of customers actually, service providers, are not looking at that solution, but more encapsulation stuff, like Telecom Italia with dual stack, with Juniper, not us. Nobody's perfect, but so plenty of solutions. And why plenty of solutions for them? Because their network is different. And if you're a large service provider, even yourself has different network topology or design or, yeah, in your whole infrastructure. Some old regions may have only v4. Some new regions may have only v6. Some other regions may have dual stack. So I'm a very large service provider. I don't have symmetry everywhere. I have some stuff in some places, some stuff in other places. And depending on what you have, this solution will help or that solution will help. So, so yeah, that's much more complex for service providers than the enterprise. So how do you test for the service providers? Enterprise, if you remember, that's pretty easy. You own your application, so it's easy to test your application. You just test your application with v6 clients. And you test your applications with v6 clients the same way you test your application with v4 clients. You test them with Windows, with Mac, with Firefox, with IE, and Chrome. And you have a test lab, not a test lab, you have a test procedure, and you run that to be sure everything works fine. So V6, you do the same, except now they're running on V6. It's very easy and controlled. Service providers, that's a nightmare for them. Why? So first you start with a lab, as the two previous people said, and you follow up in production in a controlled environment, of course, and then you deploy widely. We all agree on that. But what is the test plan? For service providers, that's a nightmare, because end users can do anything, and they do anything. So they go on websites, sure. They do P2P applications, Skype. They do gaming, and they do have Linux, Windows, Mac with different challenges, as people talked before. So they do voice over IP. They do, crazy things. And of course, they don't want to. They want all their customers happy. So they have to test all of that. So for them, the job is much, much harder. They have plenty of technologies available, and they have to test many, many, many things. So, yeah. Oh, and some points to keep in mind. Fragmentation, nobody mentioned that. Fragmentation can be a challenge also, because when you do encapsulation, let's say you have, at my home, let's say, or AT&T, they say it, they give V4 at home only. And if they want to give V6 access to customers, they encapsulate my V6 into V4, go out to a, let's call it a device, that will de-encapsulate and go out in V6. So encapsulation implies most likely fragmentation, so challenge is there. Security, people talked about it, so I won't, rephrase them. They've done a better job than I did. But so, long story short, complex for them, enterprise, easy. Now for them, service providers, actually as Brandon mentioned, ask the vendors to help you. They are here. You don't have to do everything yourself. They have proof of concept. They have seen tons of service providers with the same challenge, or not everybody is different, but with similar challenges as yours. So use them. And you have consultants that are here also with experience, field experience, because now the good news is many, many service providers, if not all, already started the job. And many of them are already in productions in control environments. So there is feedback. It's not only lab. There is feedback on how 6RD works, how DS Lite works, how NAT64, DNS64 works. So use that expertise from the vendors. And OK, vendors are who they are. So use also consultants. They are here to help. And that's it. Any question? Thank you.